In this problem, it is given that the sum of 1 with 4, 16, 64, and so on, this adds up to 5,461. Then we need to obtain the total number of terms present here. So this is a geometric progression. We can easily verify it here. The first term is a, which has a value of 1, and the common ratio r. So we can take any term and divide it by the preceding term. That's going to give us a value 4. Now we know that the sum up to the n terms of a given geometric progression Sn is given by, we have the first term multiplied to r raised to the power of n minus 1 whole divided by r minus 1. So let's plug in the value here. It's given here the sum to the n terms. So we are assuming that there are n number of terms present here. So 5,461. So this is equals to the first term multiplied to the common ratio 4 raised to the power of n minus 1 divided by 4 minus 1. Now 4 minus 1, that's 3. So we'll multiply 3 with 5,461. So this is going to give us 16,383. So this is equals to 4 raised to the power of n minus 1. Or we can simplify it to get 4 raised to the power of n, which will be equals to 16,384. Now 16,384, so that's equals to 4 raised to the power of 7. When the bases are equal, then the exponent or the power must be equal, and this tells us that there will be a 7 number of terms in a given geometric progression, which sums up to 5,461.